everyone. Today I am going to explain Introduction to Data Science Part A, Statistical Characterization of Feedback Data. So, in first we have give three more commonly used statistical measures for characterizing dispersion in student feedback data, that is variation in teaching quality scores, lab facility ratings, or peer collaboration effectiveness. Discuss how these measures can be computed effectively in large student database. Dispersion or variability measures the spread of data. It answers, are all the feedback scores clusters together around the average, or are they all over the place? Three common measures of dispersion are: first, the range. What it is? The simplest measure, it's the difference between the highest and lowest values. Formula: range is equals to maximum value minus minimum value. Example: if lab ratings are 10, 20, 50, 90, 80, the range is 90 to 10. 90 minus 10 is equals to 80. Pros: very easy and fast to calculate. Cons: extremely sensitive to outliers. 1, 0 or 100 rating can make the spread look much larger than it really is. The interquartile range, IQR, what is it? The middle 50% of the data. It's the range after you remove the top 25% and bottom 25% of scores. Formula: IQR is equals to Q375th percentile minus Q1 25th percentile. Example: for the same data, if Q1 is 20 and Q3 is 80, the IQR is 80 minus 20, which is 60. Now pros: robust to outliers. It completely ignores the extreme high and low values, giving a better sense of the typical spread. Cons: it ignores 50% of the data, the two extremes. The standard deviation and variance. What it is? The most common and powerful measure. It represents the average distance of any single data point from the mean, the average. Formula: standard deviation is equals to variance is equals to root of summation of xi minus mu ka whole square upon में n, which in simple terms mean find the mean average score, find the distance from each score to the mean, square all those distance, get the average of the squared distance, this is variance, and take the square root, this is the standard deviation. Pros होते हैं: use all the data, is very reliable and is the foundation of many other statistical tests. A small SD means scores are consistent, a large SD means opinions are highly varied. How to compute efficiently in large database? You do not pull millions of records into your program like Python to calculate these. The database engines does the work. SQL is to modern database like SQL Server, PostgreSQL, and MySQL have built-in aggregate functions that are highly optimized. Range or IQR use minimum score or maximum score and percentile functions like percentile count 0.5 with group order by score. Standard deviation or variance use the built-in stddev pop score and where pop score functions. The database calculates this one pass over the data. Select stdev pop teaching score from students feedback. Big data for billions of records. Parallel systems uses MapReduce approach to calculate the sum count and sum of squares in parallel and then combine them at the end to get the final variance. Suppose that the student feedback rating a scale of 1 to 100 on faculty's mentoring effectiveness is given in a sorted order and some sort of numbers it is given. What is the mean rating? We have to find the mean, median, mode of the data, modality, bimodal, trimodal. What is the mean range of the data? Estimate first quartile or third quartile nikala. We have to give the 5-number summary of the ratings, draw blocks plot of the data. How is the quantile plot different from a quantile plot in the context? So we have some given data of n is equals to 26. So we we have to find its mean range by putting it into a formula. So we will draw a box plot of the data. How is the quantile plot different from a quantile plot in this context? A quantile plot would simply plot the feedback scores on the y-axis against their rank or fractional position on the x-axis. It's a way to visualize the distribution of this one set of scores. A quantile QQ plot would plot a feedback scores against the quantile of another distribution, typically the normal distribution. We would use it to see our student feedback scores look normal. If the points from a straight line, it suggests our data is normally distributed. Now we have suppose a student lab infrastructure satisfaction scores are grouped into intervals with the following distribution. We have score range, we have frequency of students, compute an approximation median satisfaction score for students. We have to create a cumulative frequency table which have a score range from 1 to 5, class boundaries in the decimal and frequencies, and cumulative frequencies. Step 2 is to find the median position. Total students n is equals to 3194 and median position n by 2 is equals to 1597. We are looking for the score for the 1597th student. Okay, now we have third step to identify the median class. The 1597th student is past the 950th student in the 16 to 20 class and is within the next group, which goes up to the 2450 students. Therefore the median class is 21 to 50. Step 4 to compute using the median formula. Median is equals to L plus n by 3 minus CF cumulative frequency upon frequency into W. So L is equals to lower boundary of the median class, which is 20.5, n by 2 is equals to median position, which is 1597, CFB cumulative frequency before the median class, which is 950, FM frequency of the median class, which is 1500, W is the width of the median class, which is 30. So we will calculate it by putting it in the formula. And in the Department of Lifelong Learning, a feedback survey collected both students' age and their self-assessment of learning productivity percent for 18 students. Now we have age in numbers and percentiles we have. Now we'll calculate the mean, median and standard deviation of age and percentage productivity. Draw the plot spots for both and draw a scatter plot and a QQ plot to study the relationship. First we have to find mean, median and standard deviation. Then we'll find the body fat percentage, which is mean is equals to 28.78, median is equals to 30.7 and standard deviation is equals to 9.25. Box plot, we'll draw it of box plot of age and box plot of body fat percentage. Now scatter plot and QQ plot. Scatter plot displays the relationship between age and body fat percentage, and QQ plot assesses whether the body fat percentage follows a normal distribution. Now we'll come. So this is it. This is our first part of internal